All right, in this video, we're going to look at the vertex form of the parabola. That is, you know, when we change some numbers, add, subtract, throw a number that's being multiplied in front, how that actually changes the look of the parabola. So we're going to start off with y is equal to 2 times x minus 4 squared minus 8. So if we look at that, there's a few things going on. First of all, we can see that there's a vertical stretch. It's not upside down, though, because it's a positive 2. So the parabola is stretched vertically by a scale factor of 2, and it's been moved, so that's a vertical stretch. Okay. Now, if you remember, the number that's being subtracted from x is kind of like the new x location of the vertex. So another way of thinking of that, it's kind of like opposite, right? So we've been moving 4 units since we're subtracting. It's actually moving to the right. So 4 units to the right. And this is 8 down. Okay, so that's a big thing to get. All right, so if you move the vertex from 0, 0, 4 units to the right and 8 down, okay, it used to be there. 4 units to the right is going to take me there, and 8 down means my new vertex is 4, negative 8. Okay, so kind of why we call it vertex form, because it's easy to see that the vertex is 4, the number that's being subtracted, minus 8. Okay, so now that we have that, so where's the vertex move to? Well, 4, negative 8. What is the direction of opening? Well, since that's still positive 2 that's being multiplied in front, it's going to open up. So now from our vertex, let's grow the parabola, vertically stretching our ups by 2. So instead of 1 over 1 up, it's 1 over 2 up. Gotta figure out why my thing disappears every once in a while, but not today. Okay, so we're gonna get that. Let me zoom in. Okay, growing the parabola by a scale factor of 2. So 1 over, I already did it wrong. Let me go back. Okay, so my vertex is at 4, negative 8. It's normally 1 over 1 up, so I'm going to go 1 over 2 up, twice as much as I normally would go because of the vertical stretch of 2. Then my next set of points is 2 over 4 up becomes 2 over 8 up. And then my next set of points after that is normally 3 over 9 up, so I'm actually going to go 3 over 18 up. And let's see if I can actually fit that on here. So I'm 8 below, so if I go all the way up to 10 above, I'm just going to fit that one on. So 3 out from the center, and 18 up takes me to there and there. So putting it all together, I get this vertically stretched parabola by a scale factor of 2, so it's twice as tall, kind of stretched out as it used to be. And it's been moved 4 to the right, 8 down, so that its new vertex location is 4, negative 8. All right. So graphing it is, so just like a line had y equals mx plus b, and you could kind of graph it that way, the vertex form is kind of like the parabola's way of graphing it. Okay, the equation of the axis of symmetry for E. Remember, the axis of symmetry is a vertical line that goes right down the middle, like so. That vertical line has the equation x equals 4, because all of its x coordinates on all of its points are 4. So that is the axis of symmetry. Okay, so when it asks for the equation, we can't just say 4. We have to give the equation of the line as if we were to graph it. x equals 4. Is there a max or a min? Well, since this thing kind of opens up, there's a minimum of, nope, not 4. Minimum refers to, maximum minimum refers to the y value, okay? So the minimum, again, it's like the minimum y value that we can have on this parabola is -8. Okay, that's as low as we go. The domain of the parabolas this year is always going to be pretty much all reals. So let's do it in interval notation. So the domain is any value from -x or negative infinity to positive infinity is on that graph. But the y values, the lowest one is -8, and it goes all the way up from there. So the range for y values is going to be from -8. I've been doing too many of these videos. I can't remember how to make an 8. 8, -8, all the way up to positive infinity, square bracket, because you can equal -8. Infinity has the round bracket. All right, so that's the domain range. The x and the y-intercept. Okay. We are going to look at a couple of different ways. First of all, x-intercept is where our graph crosses or intercepts the x-axis. So the x-intercepts are clearly 2 and 6. Okay? All right. If you guys remember from last year, we can also mathematically figure out where those x-intercepts are. So let's take our equation, which was y is equal to 2x minus 4 squared minus 8. Okay, if you remember last year, to find the x-intercept, you make y equal to 0. Why do we do that? Well, if we know we're looking for a point that's sitting on the x-axis, we know it's got to have a y-coordinate of 0. Okay? So that's why we plug in 0 for our y. Okay, so now we're going to go through and solve this thing for x. So when we're solving this equation, there are a bunch of steps that we have to do to kind of get at that x. So first thing we might want to do here is we might want to add 8 to both sides to start stripping away things on that right side. So that's 8 is equal to 2x minus 4 squared. That cancels. Okay. Next thing that we might want to do is we have 2 times the thing in brackets, so we can divide both sides by 2. All right. 8 divided by 2 is 4. So we have that. Okay. Next, we're going to square root both sides. Now, here's where solving this equation gets a little bit tricky. Okay? So I'm going to take a little aside here and just talk about solving square roots for a second. All right? So I'm just going to go over on the side. Okay, if we solve square root as an equation by square rooting, let's look at this equation. X squared equals 25. How many numbers would we be able to substitute in for x to make this a true statement? Well, x could be positive 5, because if we were to plug that in, 5 squared is equal to 25. So that works. But x could also be negative 5, because if we were to plug that into the equation, we'd have negative 5 squared also equals 25, because if you square a negative, you get positive. So there's actually 2 solutions to this equation. Okay? So in a quadratic equation, that is, when that's squared, you can kind of expect 2 solutions. So the problem is, let's say we were to square root both sides. Okay? If you use the square root key on your calculator, or using that square root radical sign, the square root of 25 only means the positive square root. So the square root of x is just 5. It's not negative 5. So if I square rooted both sides, I'm going to get 5, but I'm not going to get this one. Okay? Because square rooting with that radical sign that you guys remember from grade 10 doesn't give you the negative 5 part. So what you have to remember is, if you use square roots to solve an equation, you have to remember that when I square root the 4, it could be negative square root of, it could be the negative or positive. Okay? So positive, negative, square root of 4 is 2. So if I square root 4, remember, it could be positive or negative, just like we had in the example in my little bubble there. Okay? So the square root of 4 is 2, positive or negative. So square root and square cancel each other off, so I'm just left with x plus 4. Then I'm going to add 4 to both sides to get rid of the 4. And this looks a little bit weird, but I have positive or negative 2 plus 4 is equal to x. Well, what this little statement here is telling me that there's actually two answers here. So there's two answers to this equation. There's positive 2 plus 4 and negative 2 plus 4, because of the two options for positive and negative 2. Well, positive 2 plus positive 4 is 6, and negative 2 plus 4 is 2. So I get two solutions to this equation for my x-intercepts, which is totally what I want, because if I go back up to the graph, okay, that's completely what's going on there. If I go back to the graph, I have 2 and 6. I have two answers to that equation that I was solving to find the x-intercept. So when you guys are looking for the x-intercept and you're square rooting, you're using square root to solve the equation, like right there, you have to plus or minus the square root of the number that you're square rooting. Okay? All right, to find the y-intercept is much easier, because to find the y-intercept, we make x equal to 0, which is way easier because that's just plugging in x into this equation. So 0 plus 4 squared minus 8, y is equal to 2 times 0 and minus 4 is negative 4. So then that's 2, and now next we get a square, so negative 4 times negative 4 is 16. 2 times 16 is 32 minus 8, and 32 minus 8 is 24. So this parabola crosses the y-axis when y is 24. If we go back up to the equation, you can see that's probably true, that way up there, if we keep growing this parabola, it's eventually going to cross the y-axis at 24. All right, so there's a whole lot of stuff that went on in that question. In the next two examples, we are going to work with a parabola and see if we can come up with what the equation is in vertex form. Okay, so let's take a look at this parabola. First of all, let's look at how its vertex has been moved. I'm just going to move, there we go. Okay, so how has its vertex been moved? Well, the vertex to a parabola is always there. So we can see it's been moved 2 to the left and 1, 2, 3 up. Okay, that right away tells us that our equation is going to be maybe some numbers, some a thing is going to stretch it. 2 to the left is x plus 2, right, because it's opposite. Okay, so that means 2 to the left. 3 up means plus 3. So our equation for the parabola, we've already kind of like done the movement into the right spot. So 2 to the left, 3 up is reflected in our statement that we just wrote. Okay, so the one thing we got to do is, how has this thing been stretched? Well, let's take a look at it a little bit more closely, and let's see how it's grown from its thing there. First of all, it's been growing upside down, so we know A is negative. Okay, so let's say I was to grow this thing normally from my vertex red dot. I would normally go 1 over 1 up, 2 over 4 up. Okay, that would be my normal parabola. But let's look at what happened instead. Okay, instead of going 1 over 1 up, I went 1 over, but instead of going 1 up, I actually went 1, 2 down. So there's an upside down thing happening, and there's also a vertical stretch by a scale factor of 2. Okay, let's just make sure that that's true with the second point, just to sort of make sure we got it. So the second point, if we were to grow it normally from this vertex, it would be 2 over 4 up, because 2 squared is 4. But let's see what we did. We went 2 over, but this time we went 1, 2, 3, 4, 5, 6, 7, 8. We went 8 down. So that confirms that we're not only going down instead of up, but we're also doing a scale factor of 2, okay? Stretching it vertically. So that tells us that the equation of this parabola in vertex form is -2, okay, to make it go upside down and stretch, x plus 2 to make it go 2 to the left squared, because it's quadratic, plus 3. Bada bing, bada boom. Okay? All right. So you guys can pause the video and try this one and that whole thing. And let's look at it together. So what is the equation of this parabola? Well, let's look at kind of how it's changed. All right. So it's, first of all, its vertex has gone 2 to the right, 1 down. Okay? So y is going to be equal to some stretch thing, maybe. 2 to the right is going to be x minus 2, okay? Because that means to the right squared. And 1 down, minus 1. Okay, so the only thing is we got to figure out is, has it been stretched by any scale factor? All right, so let's say there's our vertex. Let's grow the parabola normally, how we do it. So from the vertex, we'd usually go 1 over. Dang it. Try that again. 1 over, 1 up. So our normal point would be there and there. Okay. Then we'd go 2 over, 4 up. 1, 2, 3, 4. So it would normally be there and there. Okay. So let's compare to what the actual parabola does compared to that. Well, let's do this point here. Instead of going 2 over 4 up, we can see it's 2 over only 2 up. So it appears as though it's going up half its normal amount. Okay? So that tells us that the vertical stretch is half. Let's do this point now to show that's true as well. Normally, it's 1 over 1 up, but this time we're going 1 over only half the way up. Okay, that's only half the way up. So, in other words, our a value is half x minus 2 squared minus 1. So we've taken care to vertically stretch this thing by a scale of half. 2 to the right, 1 down takes us to our new location for our vertex, which is 2, -1. And we've made sure that we've had the squared in there because we need to show that this is a parabola. It's a quadratic graph. It's squared. Okay? So that would be the vertex form of this parabola. And I did something to make things erase. All right, there we go. So that is our final answer for the vertex form of the parabola that you see before you. All right, so I think I'm done before I start babbling even more. End of video. See ya.